In this chapter, we are going to discuss the static testing techniques. Testing is not always about executing the code and finding the defects, but it is also about checking the requirements for ambiguities, checking the design to see if all the requirements have been implemented or not. All these techniques are part of static testing and are done during the early phases of software development life cycle. Testing is not only about executing the code and checking the outcome, dynamic testing, but it also involves studying program code, static testing. Today, not all testers of software applications read code, but the concept of studying program code as part of a testing effort certainly is widely accepted. Several factors may affect the likelihood that a given testing and debugging effort will include people actually reading program code, the size or complexity of the application, the size of the development team, the timeline for application development, whether the schedule is relaxed or intense, for example, and, of course, the background and culture of the programming team. Static test techniques provide a powerful way to improve the quality and productivity of software development. The fundamental objective of static testing is to improve the quality of software work products by assisting engineers to recognize and fix their own defects early in the software development process. While static testing techniques will not solve all the problems, they are enormously effective. Static techniques can improve both quality and productivity by impressive factors. The definition of testing outlines objectives that relate to evaluation, revealing defects and quality. As indicated in the definition, two approaches can be used to achieve these objectives: static testing and dynamic testing. With dynamic testing methods, software is executed using a set of input values, and its output is then examined and compared to what is expected. During static testing, software work products are examined manually, or with a set of tools, but not executed. Among the questions that arise are: how can we evaluate or analyze a requirements document, a design document, a test plan, or a user manual? How can we effectively pre-examine the source code before execution? One powerful technique that can be used is static testing, e.g. reviews. In principle, all software work products can be tested using review techniques. Dynamic testing and static testing are complementary methods, as they tend to find different types of defects effectively and efficiently. Types of defects that are easier to find during static testing are deviations from standards, missing requirements, design defects, non-maintainable code, and inconsistent interface specifications. Note that in contrast to dynamic testing, static testing finds defects rather than failures. In addition to finding defects, the objectives of reviews are often also informational, communicational, and educational, whereby participants learn about the content of software work products to help them understand the role of their own work and to plan for future stages of development. Reviews often represent project milestones and support the establishment of a baseline for a software product. The type and quantity of defects found during reviews can also help testers focus their testing and select effective classes of tests. In some cases, customers/users attend the review meeting and provide feedback to the development team, so reviews are also a means of customer/user communication. To summarize, the use of static testing, e.g. reviews, on software work products has various advantages. 1. Since static testing can start early in the life cycle, early feedback on quality issues can be established, e.g. in a early validation of user requirements, and not just late in the life cycle during acceptance testing. 2. By detecting defects at an early stage, rework costs are most often relatively low, and thus a relatively cheap improvement of the quality of software products can be achieved. 3. Since rework effort is substantially reduced, development productivity figures are likely to increase. 4. The evaluation by a team has the additional advantage that there is an exchange of information between the participants. 5. Static tests contribute to an increased awareness of quality issues. In conclusion, static testing is a very suitable method for improving the quality of software work products. This applies primarily to the assessed products themselves, but it is also important that the quality improvement is not achieved once, but has a more structural character. The feedback from the static testing process to the development process allows for process improvement, which supports the avoidance of similar errors being made in the future. Reviews vary from very informal to formal, i.e. well-structured and regulated. Although inspection is perhaps the most documented and formal review technique, it is certainly not the only one. The formality of a review process is related to factors such as the maturity of the development process, any legal or regulatory requirements, or the need for an audit trail. In practice, the informal review is perhaps the most common type of review. Informal reviews are applied at various times during the early stages in the life cycle of a document. A two-person team can conduct an informal review, as the author can ask a colleague to review a document or code. In later stages, these reviews often involve more people and a meeting. This normally involves peers of the author who try to find defects in the document under review and discuss these defects in a review meeting. The goal is to help the author and to improve the quality of the document. Informal reviews come in various shapes and forms, but all have one characteristic in common: they are not documented. In contrast to informal reviews, formal reviews follow a formal process. A typical formal review process consists of 6 main steps. 1. Planning. 2. Kickoff. 3. Preparation. 4. Review meeting. 5. Rework. 6. Follow-up. The first process in a formal review process is planning. The review process for a particular review begins with a request for review by the author to the moderator or inspection leader. A moderator is often assigned to take care of the scheduling, dates, time, place, and invitation of the review. On a project level, the project planning needs to allow time for review and rework activities, thus providing engineers with time to thoroughly participate in reviews. For more formal reviews, e.g. inspections, the moderator always performs an entry check and defines at this stage formal exit criteria. The entry check is carried out to ensure that the reviewer's time is not wasted on a document that is not ready for review. A document containing too many obvious mistakes is clearly not ready to enter a formal review process, and it could even be very harmful to the review process. It would possibly demotivate both reviewers and the author. Also, the review is most likely not effective because the numerous obvious and minor defects will conceal the major defects. Although more and other entry criteria can be applied, the following can be regarded as the minimum set for performing the entry check. A short check of a product sample by the moderator or expert does not reveal a large number of major defects. For example, after 30 minutes of checking, no more than 3 major defects are found on a single page, or fewer than 10 major defects in total in a set of 5 pages. The document to be reviewed is available with line numbers. The document has been cleaned up by running any automated checks that apply. References needed for the inspection are stable and available. The document author is prepared to join the review team and feels confident with the quality of the document. If the document passes the entry check, the moderator and author decide which part of the document to review. Because the human minds can comprehend a limited set of pages at one time, the number should not be too high. The maximum number of pages depends, among other things, on the objective, review type, and document type A, and should be derived from practical experiences within the organization. For a review, the maximum size is usually between 10 and 20 pages. In formal inspection, only a page or 2 may be looked at in depth in order to find the most serious defects that are not obvious. After the document size has been set and the pages to be checked have been selected, the moderator determines, in cooperation with the author, the composition of the review team. The team normally consists of 4 to 6 participants, including moderator and author. To improve the effectiveness of the review, different roles are assigned to each of the participants. These roles help the reviewers focus on particular types of defects during checking. This reduces the chance of different reviewers finding the same defects. The moderator assigns their roles to the reviewers. Within reviews, the following focuses can be identified. 1. Focus on higher-level documents, e.g. does the design comply to the requirements? 2. Focus on standards, e.g. internal consistency, clarity, naming conventions, templates. 3. Focus on related documents at the same level, e.g. interfaces between software functions. 4. Focus on usage, e.g. for testability or maintainability. The author may raise additional specific roles and questions that have to be addressed. The moderator has the option to also fulfill a role, alongside the task of being a review lead-up. Checking the document improves the moderator's ability to lead the meeting, because it ensures better understanding. Furthermore, it improves the review efficiency, because the moderator replaces an engineer that would otherwise have to check the document and attend the meeting. It is recommended that the moderator take the role of checking compliance to standards, since this tends to be a highly objective role, which leads to less discussion of the defects found. The second step in a formal review process is kickoff. The goal of this meeting is to get everybody on the same wavelength regarding the document under review, and to commit to the time that will be spent on checking. Also, the result of the entry check and defined exit criteria are discussed in case of a more formal review. In general, a kickoff is highly recommended since there is a strong positive effect of a kickoff meeting on the motivation of reviewers and thus the effectiveness of the review process. During the kickoff meeting, the reviewers receive a short introduction on the objectives of the review and the documents. The relationships between the document under review and the other documents, sources, are explained, especially if the number of related documents is high. Role assignments, checking rate, the pages to be checked, process changes, and possible other questions are also discussed during this meeting. Of course, the distribution of the document under review, source documents, and other related documentation can also be done during the kickoff. The next step is preparation of the review process. The participants work individually on the document under review using the related documents, procedures, rules, and checklists provided. The individual participants identify defects, questions, and comments according to their understanding of the document and role. All issues are recorded, preferably using a login form. Spelling mistakes are recorded on the document under review, but not mentioned during the meeting. The annotated document will be given to the author at the end of the logging meeting. A critical success factor for a thorough preparation is the number of pages checked per hour. This is called the checking rate. The optimum checking rate is the result of a mix of factors, including the type of document, its complexity, and the number of related documents, and the experience of the reviewer. Usually the checking rate is in the range of 5 to 10 pages per hour, but may be much less for formal inspection, e.g. 1 page per hour. During preparation, participants should not exceed this criterion. By collecting data and measuring the review process, company-specific criteria for checking rate and document size, planning phase, can be set, preferably specific to a document type. The next is the review meeting. The meeting typically consists of the following elements, partly depending on the review type: logging phase, discussion phase, and decision phase. During the logging phase, the issues, e.g. defects, that have been identified during the preparation are mentioned page by page, reviewer by reviewer, and are logged either by the author or by a scribe. A separate person to do the logging, a scribe, is especially useful for formal review types such as an inspection. To ensure progress and efficiency, no real discussion is allowed during the logging phase. If an issue needs discussion, the item is logged and then handled in the discussion phase. A detailed discussion on whether or not an issue is a defect is not very meaningful, as it is much more efficient to simply log it and proceed to the next one. Furthermore, in spite of the opinion of the team, a discussed and discarded defect may well turn out to be a real one during rework. Every defect and its severity should be logged. The participant who identifies the defect proposes the severity. Severity classes could be critical. Defects will cause downstream damage. The scope and impact of the defect is beyond the document under inspection. Major defects could cause a downstream effect, e.g. a fault in a design can result in an error in the implementation. Minor defects are not likely to cause downstream damage, e.g. non-compliance with the standards and templates. In order to keep the added value of reviews, spelling errors are not part of the defect classification. Spelling defects are noted by the participants in the document under review and given to the author at the end of the meeting, or could be dealt with in a separate proofreading exercise. During the logging phase, the focus is on logging as many defects as possible within a certain time frame. To ensure this, the moderator tries to keep a good logging rate, number of defects logged per minute. In a well-led and disciplined formal review meeting, the logging rate should be between 1 and 2 defects logged per minute. For a more formal review, the issues classified as discussion items will be handled during this meeting phase. Informal reviews will often not have a separate logging phase and will start immediately with discussion. Participants can take part in the discussion by bringing forward their comments and reasoning. As chairman of the discussion meeting, the moderator takes care of people issues. For example, the moderator prevents discussions from getting too personal, rephrases remarks, if necessary, and calls for a break to cool down heated discussions and /or participants. Reviewers who do not need to be in the discussion may leave or stay as a learning exercise. The moderator also paces this part of the meeting and ensures that all discussed items either have an outcome by the end of the meeting or are defined as an action point if a discussion cannot be solved during the meeting. The outcome of discussions is documented for future reference. At the end of the meeting, a decision on the document under review has to be made by the participants, sometimes based on formal exit criteria. The most important exit criterion is the average number of critical and /or major defects found per page, e.g. no more than 3 critical/major defects per page. If the number of defects found per page exceeds a certain level, the document must be reviewed again after it has been reworked. If the document complies with the exit criteria, the document will be checked during follow-up by the moderator or one or more participants. Subsequently, the document can leave the review process. After having the review meeting and identifying the defect, the next process is reworking the document to remove defects. Based on the defects detected, the author will improve the document under review step by step. Not every defect that is found leads to rework. It is the author's responsibility to judge if a defect has to be fixed. If nothing is done about an issue for a certain reason, it should be reported to at least indicate that the author has considered the issue. Changes that are made to the document should be easy to identify during follow-up. Therefore, the author has to indicate where changes are made, e.g. using track changes in word processing software. The last process in a formal review is the follow-up. The moderator is responsible for ensuring that satisfactory actions have been taken on all logged defects, process improvement suggestions, and change requests. Although the moderator checks to make sure that the author has taken action on all known defects, it is not necessary for the moderator to check all the corrections in detail. If it is decided that all participants will check the updated document, the moderator takes care of the distribution and collects the feedback. For more formal review types, the moderator checks for compliance to the exit criteria. In order to control and optimize the review process, a number of measurements are collected by the moderator at each step of the process. Examples of such measurements include number of defects found per page, time spent checking per page, total review effort, etc. It is the responsibility of the moderator to ensure that the information is correct and stored for future analysis. The two primary human testing methods are code inspections and walkthroughs. Since the two methods have a lot in common, we will discuss their similarities together here. Their differences are discussed in subsequent sections. Inspections and walkthroughs involve a team of people reading or visually inspecting a program. With either method, participants must conduct some preparatory work. The climax is a meeting of the minds at a participant conference. The objective of the meeting is to find errors, but not to find solutions to the errors. That is, to test, not debug. Code inspections and walkthroughs have been widely used for some time. In a walkthrough, a group of developers with 3 or 4 being an optimal number performs the review. Only one of the participants is the author of the program. Therefore, the majority of program testing is conducted by people other than the author, which follows the testing principle stating that an individual is usually ineffective in testing his or her own program. An inspection or walkthrough is an improvement over the older desk checking process, the process of a programmer reading his or her own program before testing it. Inspections and walkthroughs are more effective, again because people other than the program's author are involved in the process. Another advantage of walkthroughs, resulting in lower debugging, error correction costs, is the fact that when an error is found it is usually precisely located in the code. In addition, this process frequently exposes a batch of errors, allowing the errors to be corrected later and messy. Computer-based testing, on the other hand, normally exposes only a symptom of the error, the program does not terminate, or the program prints a meaningless result, and errors are usually detected and corrected one by one. These methods generally are effective in finding from 30 to 70% of the logic design and coding errors in typical programs. They are not effective, however, in detecting high-level design errors, such as errors made in the requirements analysis process. A code inspection is a set of procedures and error detection techniques for group code reading. Most discussions of code inspections focus on the procedures, forms to be filled out, and so on. Here, after a short summary of the general procedure, we will focus on the actual error detection techniques. An inspection team usually consists of 4 people. One of the 4 people plays the role of moderator. The moderator is expected to be a competent programmer, but he or she is not the author of the program and need not be acquainted with the details of the program. The duties of the moderator include 1. Distributing materials for and scheduling the inspection session. 2. Leading the session. 3. Recording all errors found. 4. Ensuring that the errors are subsequently corrected. The moderator is like a quality control engineer. The second team member is the programmer. The remaining team members usually are the program's designer, if different from the programmer, and a test specialist. The moderator distributes the program's listing and design specification to the other participants several days in advance of the inspection session. The participants are expected to familiarize themselves with the material prior to the session. During the session, 2 activities occur. 1. The programmer narrates, statement by statement, the logic of the program. During the discourse, other participants should raise questions, and they should be pursued to determine whether errors exist. It is likely that the programmer rather than the other team members will find many of the errors found during this narration. In other words, the simple act of reading aloud a program to an audience seems to be a remarkably effective error detection technique. 2. The program is analyzed with respect to a checklist of historically common programming errors. The moderator is responsible for ensuring that the discussions proceed along productive lines, and that the participants focus their attention on finding errors, not correcting them. The programmer corrects errors after the inspection session. After the session, the programmer is given a list of the errors found. If more than a few errors were found, or if any of the errors requires a substantial correction, the moderator might make arrangements to re-inspect the program after the errors are corrected. This list of errors is also analyzed, categorized, and used to refine the error checklist to improve the effectiveness of future inspections. As stated, this inspection process usually concentrates on discovering errors, not correcting them. However, some teams may find that when a minor problem is discovered, 2 or 3 people, including the programmer responsible for the code, then propose obvious patches to the design to handle this special case. The discussion of this minor problem may, in turn, focus the group's attention on that particular area of the design. During the discussion of the best way to patch the design to handle this minor problem, someone may notice a second problem. Now that the group has seen 2 problems related to the same aspect of the design, comments likely will come thick and fast, with interruptions every few sentences. In a few minutes, this whole area of the design could be thoroughly explored, and any problems would be obvious. The inspection process also has several beneficial side effects in addition to its main effect of finding errors. For one thing, the programmer usually receives feedback concerning programming style, choice of algorithms, and programming techniques. The other participants gain in a similar way by being exposed to another programmer's errors and programming style. Finally, the inspection process is a way of identifying early the most error-prone sections of the program, helping to focus more attention on these sections during the computer-based testing processes.